Okay, let's get going here, please. Okay, so can we go here, guys? All right. In calculus, we'll only be using radians for everything. That said, I have taught calculus 4 times and 11 to you 23 times, so I may accidentally slip into degrees when I'm talking special triangles and stuff like that, but I really don't. I really should be using radians here. Okay. What is a radian, please? Oh goodness. Yes, good. Okay. It does involve pi. Okay. What did you? Basically, where it comes from is that it comes from a circle. There are 2 pi radians in a circle. Therefore, pi radians is equal to 180 degrees. That's the conversion factor. Okay. So what a radian actually equals then, continuing on with my math, is 180 degrees divided by pi. Now, as far as what a radian technically is, okay, it's a measure of the arc length. Did you guys say arc length? Have you heard of that? Did I say that before? Okay. So if I do pi by 4, it's actually this measures pi by 4 is the arc length of the circle is pi by 4. Okay, that's where it comes from. Is that making sense for people? This is coming back for advanced functions? No? Okay, it should be. Okay. All right, a few other things that we should know here for this is unit circle. And this is, if you're in my grade 11 class, you're going to be tortured by this again today, but go with me. I'm going to pick any old unit called point P, which we're going to call X and Y. Theta is going to be something like that. Okay? Theta, 0 radians or 0 degrees is measured from the positive x-axis, and it rotates around the circle like this. All right? I'm going to do a quick little zoom in. Like this. Oh, goodness. Okay, can somebody help me to remember what the 3 different sides of that triangle is going to be? What's the length of the hypotenuse of that triangle going to be, please? I'm too fast. I'm sorry, I'm too fast.
1.
I love trig. It is 1, but I'm going to slow down for a second. I love trig too much. That wasn't a joke. Who was laughing? Okay, good. Now let's look at let's look here. What is the right-hand side going to be from that unit circle? What's the height of that going to be? It's going to be y. Very good. Now the reason that is, right, if this is just a point we're going to call x and y, that's going to be x. What I'm going to getting into here is all the identities that we're going to start off, the fundamental identities of trig that you're going to need to memorize here. Okay? So let's start with y. I'm going to say that sine of theta from this diagram is equal to what? Let's go back to, I probably should have started before. What does sine equal? Opposite over hypotenuse. Good. So it's y over 1, which is just equal to 1. Y. Cos of theta is equal to? Base over hypotenuse, so it's equal to x. Tan of theta is y over x. This is all coming back to you guys a little bit. This is starting to come back a little bit for most people. Oh, no comments. Oh, goodness. Nate, do you remember this from grade 11? Sure. Did you guys not do this in advanced functions? You did this in advanced functions, yes? Okay, why this is useful to us is this. Using this triangle, I can say then that this is equal to sine theta, and this is equal to cos theta. This will give us our trigonometric identities, which we will need for this unit. Okay, the first one's going to be, if I have theta here, I'm going to say sine squared theta plus cos squared theta is equal to 1. So there's a Pythagorean identity. Which is sine squared theta plus cos squared theta is equal to 1. And there are many others that come from that. You can isolate sine squared theta, or you can isolate cos squared theta. This is coming back for a lot of people. So today's going to be a scribble lesson, because this is summary. Okay. If something is not clear, I'm going to quickly, please stop me. I'm hoping that some of this is going to somewhere latch on to the back of your brain somewhere from last semester or last year. The quotient identity is going to be what tan equals. What does tan equal? Right. Now the reason for that is y over x, right? So we're going to say sine theta over cos theta. Very nice. Okay, this is coming back to people. Katie, you're good? This is starting to come back, yes? Let's look for this one. I'm not going to prove this one because I don't really want to. But this is one that you're going to need to know. Did Mr. Kemp make you prove this last try? I hope he did. Yes, he did. Okay, what this one actually equals is sine. Oh, I don't know enough room. This is so good identity. This is so good identity. I'm going to the next board here. This is equal to sine A cos B plus sine B cos A. This is something that you must commit to memory if it is not committed to memory as of yet. Okay, these four things I'm listing. Okay, you don't need to prove them anything, but you need to know them. Sine of A minus B. Yes, same thing. Cos of A plus B. And cos of A minus B. Okay, with that there, that's enough to memorize to get you through this course. Okay, well, I'm going to derive a whole bunch of things from those fundamental 6 things, but those are the ones that you have to have down in your brain that we'll be using most of the time. Okay? Those look somewhat familiar to me. I'm not going to ask you to prove them or anything like that, right? But like, let's say, for instance, we're taking the derivative of sine of something. You might have to split it apart to that big massive pair or something like that. Okay? From there, we can get tons of other things. Okay? The main one we can get is, well, there's lots. What would sine 2a equal?
2 sine of
Okay, you got that. Yeah. Yeah, A twice and B twice. Okay. Good. What's cos of 2a equal to? What's cos of 2a equal to? All right. Okay, do I need to show this out? No problem. I'll show it out. So this is equal to cos A plus A. Right? So this is going to be equal to then cos A minus sine A, which is cos squared A. Okay, I know I'm going too fastly here. Is this somewhat coming back to people? Nate, I'm picking on you. Is this coming back? It's starting to come back though from advanced functions. Matt, I know it's been a year and a half for you.
Yeah, it's not coming back, but it makes sense.
You're honest, that's good. Okay. But these 6 things on the left-hand board, these are the 6 biggies for this course, okay? All right. Okay, let's do a few other things here now. There's a few other rules that we should use here. Let's go for sine of pi over 2 minus, actually, let's do unit circle first. Actually, sorry, I erased that. Sorry about that. Let's do special triangles first. And other things to know from unit circle. All right. Please remember that everything comes from the unit circle. Every single thing that you do here. Okay? As a reminder, so I'm going to draw a big giant circle to help us out here. pick on you. That's a bad move today. Okay, this is going to be 0 radians right there, right? How many radians is it going to be at the top? 5 or 2. How'd you get that?
Just half of a circle is 5 radians.
Yeah, half the circle is 5, so 4 is going to be 3, 5. Now remember, this is called a periodic function sine and cosine, right? Because theoretically I can go around the circle again and again and again and again and again. Right? So also remember, I've got Emily for this if you do not mind. On the unit circle, what is sine and what is cos? You look back in your notes. Just wait through the time. What's sine equal to? Good. And cos is equal to? Yeah, so what you said. Okay, good. So from this here, I'm just going to quickly go through where it graphs and where everything comes from, okay? If I say sine of 0, what is sine of 0 going to be from the unit circle? How would I find that? Sine of 0? Zero, good, thank you, okay? Now the reason that is, it's the y value here. The y value of 0 degrees is 0, right? Okay? Once you get up to here, what's sine of pi by 2 going to equal? 1, okay? What's sine of pi going to be? Good. What's sine of 3 pi by 2 going to be? -1. Okay, we get the logic of what happened there? Because it's just going to be your y values going around here, all right? Same thing for the x. What's cos of 0 going to be? 1, because your x value here is going to be 1 at 0 degrees. Cos of pi by 2 is going to be, right? Cos of pi is going to be, say 1, and cos of 3 pi by 2. Okay, do you get the logic of how we work our way around the circle to get those? No? Okay. So one shake of the head. So this is the point right here. This is 1 comma 0. This is 0 comma 1. This is -1 comma 0, and this is -1 comma -1. Right, those are like the 4 coordinate points going around the circle. So at 0 degrees, you just proved on the last board that sine of theta was equal to the y coordinate, right? So all we're saying is at
The
0.
bottom is
Yeah,
0,
bottom.
0, 1, because
You guys are right on the ball, Sarah. Are we good now? We're now good? All right, thank you. So we said the sine is the y value, so at 0 degrees the y value is 0. Okay, at 90 or pi by 2, we're up to 1. Okay, at 180, we're back to 0, and then -1. And this will turn into a graph here in a few minutes here, okay, but that's where the points are coming from. Okay. All right, here we go, special triangles. Let's do the pi by 4, oh, this is messy. By 2 triangle. If you need that translated, could somebody translate that to degrees for me, because radians are difficult for me. Somebody get rid of your phone, please. I need you guys in your phone, please. What's pi by 4 the same as? How'd you get that, Amy? Or I can just say 180 divided by 4 is 45. So this is a 45, 45, 90 triangle. This you will definitely need. I should probably stop my video because this is going on, starting to stick on here. So what